Welcome back. Here are the notes for section 13.5. This is our last section of the chapter of the year. Make sure you put today's date up there. Alright, we're going to talk about our last trig ratios today. Today we're going to talk about sine and cosine. On your calculator you'll see it as sine, S-I-N. It's not called sin, it's sine. So sine of A is going to, again, go with your right triangles, and it's going to be the opposite leg of the angle that we're talking about. So let's talk about angle A here. Opposite leg of angle A divided by the hypotenuse. Alright, so that's the sine is opposite over hypotenuse. And cosine, C-O-S, on your calculator and for your problems here, is the adjacent leg to whatever angle you're talking about. We're talking about angle A here, over again the hypotenuse. Alright, so sine is the opposite over the hypotenuse, and cosine is the adjacent over the hypotenuse. Moving down a little bit here, we're going to just do a summary of all three of them. This symbol right here is called theta, so you're going to hear me call sine of theta here, or cosine of theta. Oops. So I'm going to mark these legs according to this angle. Hypotenuse is pretty quick to mark. It's across from the right angle. I'm going to draw an arrow across. This is the leg opposite, or the opposite leg. And the leg right next to it then is the adjacent. Alright, so we're going to go talk about the sine of theta. And again, that's going to be the opposite leg over the adjacent. Or, I'm sorry, over the hypotenuse. Cosine of theta is going to be equal to the adjacent leg over the hypotenuse. And then tangent, which we talked about yesterday, tangent of theta is the opposite leg over the adjacent. Alright, so when I'm thinking about sine, cosine, and tangent, I use something called Sohcahtoa. So Sohcahtoa is just a quick way to remember what we've got. So S-O-H-C-A-H-T-O-A. So this is the sine. I'll go back to red. Sine is right here. It's the opposite over the hypotenuse. Cosine is this middle one. It's the adjacent over the hypotenuse. And then you've got tangent there, which is the opposite over the adjacent. So a quick little thing that might help you remember what goes together. Alright, so for these triangles down here, we're going to label it, and I'm going to label it two different colors here. For angle A, I'm going to be using blue, so for my angles, I'm going to be marking this as the opposite. Here's my adjacent, I'm sorry, my sides, and the hypotenuse is going to be the hypotenuse for both of those. So looking at the sine of A, I know sine is the opposite over the hypotenuse, so the sine of A is 4 over 5. Cosine of A, I'm going to just put opposite over hypotenuse. Cosine is the adjacent over the hypotenuse, so looking at my triangle again, going from A, which is my blue markings, I'm going to go adjacent, which is 3 over the hypotenuse, which is 5. I can mark that for you. And then tangent is the opposite over the adjacent. So looking at my triangle there, the opposite is 4 over the adjacent, which is 3. And you're going to leave your answers just right there in fractions. Alright, looking at angle B, I'm going to change my color here. So now I'm going to go from B, again going across. So for angle B, my opposite is going to be here. Adjacent then is the one right next to it, and then my hypotenuse stays the same. So sine of B again is the opposite over the hypotenuse. So my opposite for B is 3 over 5. Opposite over hypotenuse. Cosine again is the adjacent over the hypotenuse. So going back to your triangle there, adjacent to angle B is 4 over 5 for my hypotenuse. And finally, tangent is my opposite over adjacent, which is going to be my 3 over 4. Again, that all is in relation to what the angle is that we're talking about there. Moving on to some examples here, solving for a variable here. I am going to look to see what I've got. Looks like I've got this angle here. So I'm going to go ahead and mark my sides. This is my opposite. The x would be my hypotenuse, and that would make my 6 my adjacent. So it looks like I have an adjacent and a hypotenuse that we're talking about. I'm going to go ahead and write my little reminder up here. Sohcahtoa. Okay, so I have an adjacent and a hypotenuse, so I'm looking for an adjacent and a hypotenuse. Looks like I'm going to be using cosine for this one. So I know that the cosine of 72 is equal to the adjacent over the hypotenuse. Then we're going to work to solve here. So the cosine of 72 on your calculator is 0.3090 equals 6 divided by x. And we're going to first get that x out of the denominator, so I'm going to multiply both sides by x. So I've got 0.3090x is equal to 6. Last step is to divide by 0.3090 to both sides. And you've got x is equal to 19.14, let's round it to 42. 416, so it pushes it up to 42. Alright, looking at our next example here, I'm going to go ahead and mark my triangles. So I see that I've got this angle right here. I'm going to go across, so I see that's my opposite. And I've got my hypotenuse here, and this is my adjacent. So looking at what I'm trying to find, I've got an opposite side and a hypotenuse side, so I'm going to use my sine function. So sine of 26 is equal to x over 200. Move this up a little bit. X over 200. Multiply both sides by 200. You can do this right on your calculator. So sine 26 times 200, that gets us to 87.67 equals x. I guess this is approximately as well because we're rounding some decimals there. Okay. A couple more examples here now. Looks like we're given some sides. We're going to work to find the angle. So I'm going to go ahead and mark my triangle. I know this is going to be my hypotenuse. And since we're solving for angle H here, I'm going to do my sides in relationship to that. So here's my opposite, here's my adjacent. So looking at what I've got, again, I've got an adjacent and a hypotenuse. So it looks like I've got cosine. So I know that cosine of H is equal to 8 over 9. This is one of those ones, since we're finding the angle, we're going to use that inverse cosine. So we're actually going to multiply both sides by cosine inverse, and then, So on your calculator, you're going to hit the second cosine inverse, and in your parentheses, you're going to put 8 divided by 9. And you've got your angle H is approximately equal to 27.27 rounded degrees here. Again, that's using that inverse cosine, so we're taking the inverse, kind of like the inverse of addition to subtraction. The inverse of a regular cosine is inverse cosine on the calculator there. Alright, looks like this time we're going to use that same triangle, but we're going to solve for angle R here. So marking it from R, I know that I have an opposite side and a hypotenuse, so I know I'm going to use sine here. So sine of R is equal to 8 over 9. Again, we're going to take the inverse of both sides, so sine -1 on this side times the sine of -1 here. So on your calculator, sine inverse of 8 divided by 9, and you get that answer for angle R is approximately, sorry about that, approximately 62.73. If I could write on my iPad right there, it'd be great. Let me fix that. Maybe not. 62.73, I'll write it again here. So 62.73 degrees is angle R. Last two examples are some real-life examples of using sine, cosine, and tangent. Again, a big key here is marking your triangles. Looking at, we're solve for angle H. It looks like we're actually not solving for angle H here. We're trying to find the height of the house. So we're solving for X here. So I'm going to circle the angle that I'm given, draw my arrow across. I've got my opposite. And then this forms a right angle down here. So here's my hypotenuse. So using my Sohcahtoa, sine is the opposite over hypotenuse. So I know that the sine of 24 equals X over 61. Solving for X here, multiply both sides by 61. Let your calculator do the work for you. So 61 times the sine of 24 is equal to X, and you've got X is equal to 24.81. Moving on to our last example here. It looks like we're solving for the height of this flagpole. So I'm going to circle my parts, draw my arrow across. So here's my opposite. This becomes my adjacent. Here's my hypotenuse. So I've got an opposite and adjacent, so I'm going to use tangent. So tangent of 36 is equal to X. Let me move this up so I can write X over 42. Solving for X then, multiply both sides by 42. Let your calculator do the work for you. So you've got 30.5148 is approximately X. Worksheet 7 is your first homework for this. Practicing that, just a good reminder for you. Sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse. Tangent is the opposite over adjacent.